Hi everyone, this is Mrs. Raposa. I'm making this video for students who may have been out or absent on June 1st. So these were the notes we took on section 9.1. You can either print out a blank copy of these notes and take notes as you watch the video, or you can print out a copy of the filled in notes and just follow along. So for right triangle trigonometry, remember that sine of any angle measure is the opposite leg length over the hypotenuse. Cosine of the angle measure will be adjacent over hypotenuse, and tangent of the angle measure will be opposite leg over adjacent leg. So for example 1, we're asked to find the angle measures in a 3, 4, 5 right triangle. So that's a right triangle with leg lengths that are 3 and 4, and the hypotenuse is 5. So what we need to do is find the angle measures. So I'm going to start by finding this one. You can start with this one if you wanted to. But in reference to this angle right here, opposite that angle is 3, so that's the opposite leg, and 4 is the adjacent leg, and 5 is the hypotenuse. So since I have all 3 lengths, I really have my pick of which one I want to use. I'm going to go with the top one, sine theta. Sine theta, sine of this angle measure, whatever that angle measure is equal to opposite over hypotenuse, so that'll be 3 over 5. So I just really need to find out what angle measure has a sine of 3/5. So to do that, I go to the calculator and I do the sine inverse of 3/5. Make sure your calculator is in degree mode. I'm going to make sure that right here, and it is. So we do the sine inverse of 3/5. Got something going on there. So sine inverse of 3/5. And that will give me 36.9 degrees approximately. So this angle measure right here is 36.9 degrees. So to find the other angle measure, I really don't need to use a sine or cosine or tangent ratio. I could if I wanted to, but it's much easier to just subtract this angle measure from 90 degrees, because in a 90 degree, in a right triangle, the two acute angles are complementary, so they're going to add up to 90 degrees. So this angle measure will be, I'll call it y. Y will equal 90 minus that 36.9 degrees, and that will give me 53.1 degrees. So y is a 53.1 degree angle. So those are the angle measures in a 3, 4, 5 right triangle. For example 2, we were given that a plane is flying at 30,000 feet. So here's our airplane right here. And it starts its descent about 130 miles from the airport. That's a typo. Actually, that should be 120 miles because I have it marked here as 120 miles. So it starts its descent 120 miles from the airport. And at what angle should the plane descend? So this is called the depression angle, or angle of descent. Right here, I'll call it, this is the angle we're looking for. And that angle at which he comes down. So this triangle right here is going to be congruent to this triangle, so this length is also 120 miles. And this length is also going to be a height of 30,000 feet. So in reference to this angle, what I have is the opposite, and I have the adjacent leg, because this is my right angle. So opposite leg and adjacent leg, that means I'm going to have to use the tangent ratio. So the tangent of that angle measure, whatever it is equal to 30,000 feet divided by 120 miles. Since they're not in the same units, I need to convert one of these to either feet or miles. So I can either convert this to miles or this to feet. I'm just going to choose to convert this to feet by multiplying that by 5,280, because 120 miles is equal to 120 times 5,280 feet, because there's 5,280 feet in a mile. So if you calculate that, that will give you 600, let me do the denominator first, 633,600 feet. And this is still 30,000 feet. So that's what the tangent of theta equals. when we put them in the same units. So now what I need to do, I can actually just reduce this. Let's put this as tangent of theta is actually 300 over 6336. And what I can do now is I could reduce that, but I really don't need to. I can just do the tangent inverse of 300 divided by 6336. And that's going to give me approximately, you know how to do the tangent inverse. So the tangent inverse of that is going to be about 2.7 degrees. A very, very small angle of depression here. I'll write that down. That's the angle of depression, angle of descent it's sometimes called, but it's 2.7 degrees, not 27 degrees. And it should be a pretty tiny angle. Since it's an airplane descending, we would not want an airplane descending at a very large angle. That would not be good for the passengers on board. So let's take a look now at example 3. So for example 3, there's no diagram shown, so we're going to draw a diagram based on the information given to us. So an observer of the space shuttle is 5.2 kilometers from the launch pad. So here's the observer, and he is 5.2 kilometers from the launch pad. Find the height of the rocket if the angle of elevation is 37 degrees. What is an angle of elevation? We talked about an angle of depression here. Well, an angle of depression means it's going down. An angle of elevation means it's going up. Now, normally we would consider that this is maybe a few feet from the floor to her eyes and look up here, but we're going to just go say that she's looking from here. So there's a 37 degree angle of elevation. So normally that would be her face looking up. That's okay. So she's looking up at a 37 degree angle at this rocket, and she wants to know what's the height of that rocket. And that's what we need to figure out. Well, in reference to that 37 degree angle, this is the opposite leg, and this is the adjacent leg. So I can just set up a tangent ratio because tangent is opposite leg over adjacent leg. So that will give me the tangent of that 37 degrees is equal to the opposite leg, which will be the height of the rocket, so I'll put h here, divided by the adjacent leg, which is 5.2. And to solve this, all I really need to do is multiply each side by 5.2 to undo division by 5.2. And I can just put that right into the calculator. What is 5.2 times the tangent of 37 degrees? I'm going to do that right over here. 5.2 times the tangent of 37 degrees, and that will give me about 3.9 kilometers. So the height of this rocket for part A is about 3.9 kilometers. Okay, so for part B, how far is the observer from the rocket? It should say from the top of the rocket. So we're looking for this distance. A little misprint. Top of the rocket? I think it said that on the other one. Okay. Yes, it did on the notes that were taken in class. So how far is the observer from the top of the rocket? So I'm looking for this distance right here. I'll label it D for distance. So for part B, this was part A. For part B, I am going to do, let's see, this is the hypotenuse. And even though I know what the opposite leg length is right here, I'm going to go with the adjacent leg length. So I can either use sine, which is opposite over adjacent, or I can use cosine, I can use sine, which is opposite over hypotenuse. I said that wrong. Or I can use cosine, which is adjacent over hypotenuse. I'm going to use the cosine. So the cosine of that angle measure is adjacent leg over D. So 5.2 over D. Now, some students in my class said, can't we just use Pythagorean theorem since I already know that this is 3.9 and this is 5.2? Yes, you could. I'm just going to use the cosine ratio. So you have a choice. To undo this, I'm just going to put it over 1 since these two fractions are equal to one another. I know that D times the cosine of 37 degrees is going to equal 1 times 5.2. You could also multiply each side by d, and you'll get the same equation I have here. Now to solve for d, all I really need to do is divide by whatever the cosine of 37 degrees is. And I really don't even need to know what the cosine of 37 degrees is to figure out the distances. I'm just going to go into the calculator and do 5.2 divided by the cosine of 37 degrees. Cosine of 37 degrees is just some decimal. So that'll give me about 6.5. So this distance right here is about 6.5 kilometers. So the answer to part B, 6.5 kilometers. And for part C, what's the angle of elevation when the height of the rocket is 30 kilometers? Oh, I changed that in our notes. Yep, so this is not the same question that's part C in the notes we took in class. This was before I revised it. So I'll get rid of this. So in our notes, the question said, what is the angle of elevation? So what's the angle of elevation? I'm going to put that here. What's the angle of elevation when the person observing the rocket, he moves 2 kilometers closer? Okay. So what is that? So I'll draw a new diagram. So a new diagram for part C. So when he's 2 kilometers closer, now he's at 3.2 kilometers away from the launch pad. So this will be 3.2. And we already know that the height of the rocket is 3.9 kilometers. And now what I need to do is find the angle of elevation right here, x degrees. So to do that, I'm just going to use tangent ratio because I have the opposite leg and the adjacent leg. So the tangent of that angle measure, whatever it is opposite over adjacent. And to do that, I'm just going to do, move it so you can see it. The tangent of that angle measures 3.9 over 3.2, so I'm just going to do the tangent inverse of 3.9 over 3.2. Put that right into the calculator. And you get about 50.6 degrees. So this one would be a 50.6 degree angle of elevation, meaning that his neck might get a little sore looking that high up. Okay, last example, example 4. A ship sails at 340 kilometers bearing of 75 degrees east, 75 degrees east. So he's going 75 degrees eastward, right? So that's a little bit northeastward, really. So he's going somewhat north and somewhat east. Ship started here. There we go, ship. And this is where he's going to end up. Okay, there's the ship. Looks like a 4 on a semicircle, but we're good. So how far north is the ship of its original position? So to do that, I need to find this one right here, this length. I need to know what this distance is north. That's the adjacent leg on this right triangle, adjacent to that 75 degree angle. And all I have is the hypotenuse. So adjacent over hypotenuse, that's the cosine ratio. So for part A, the cosine of 75 degrees is going to equal the adjacent leg, which is our north position, how far north, over 340 kilometers. So all I really need to do to each side here is multiply each side by 340, and I can do that right in the calculator by doing 340 times the cosine of 75 degrees. And that gives me 87.99, so about 88 kilometers. So this is about 88 kilometers north of where I originally started. And how far east is the ship of its original position? So actually, I have this length, I have this length. If I wanted to use Pythagorean theorem, I definitely could use the Pythagorean theorem. But just as a little bit of practice, I'm going to use a sine ratio. Sine of this angle measure is opposite leg over hypotenuse. So the sine of 75 degrees is going to give me opposite, which I don't know yet, over hypotenuse, which I do know. And again, I'm just going to multiply each side by 340, and I'll have that the position east is 340 times the sine of 75 degrees, and that gives me about 328.4 kilometers. So east is about 328.4 kilometers. And that's it for example 4.